Okay, so G-Lussac. Okay, so that one, according to our notes, had to do with pressure and temperature. So looking again at our combined gas law, and when we're reading through the problem, we would have seen pressure and temperature was all that was left. So you have P over T is equal to P over T. Okay, so this one is actually direct. The ones that look like this are direct. The only one that was inverse was Boyle's law, where they were next to each other. Okay. And actually, thank you for asking that, because I'm going to ask another question real quick. So with that question, all right, so let's read what it says. So it says a sample of helium gas has a pressure of 98 kilopascals at 24 degrees Celsius. So looking at the 24 degrees Celsius, what is that going to change into? 297 Kelvin. Okay, at what temperatures, that's who we're solving for, will the helium reach a pressure of 83 kilopascals? All right, so when I go to write out my givens here, at pressure 1, temperature 1, so we have 98. Remember, kilopascals is fine. We changed our 24 degrees Celsius to be 297 Kelvin. Pressure 2 was 83, and temperature 2 is who we're solving for. All right, so looking at these numbers, before you even plug anything in, which I know some of you guys already did, if I were to have asked you, hey, if pressure is decreasing, what's going to happen to temperature? What can you already predict here? Is it going to go up or is it going to go down? So pressure right now is going to decrease, so what's temperature supposed to do? Should decrease. Okay, so that whole thing when we talked about inverse relationships versus direct relationships, that is actually still going to play an important role, especially in questions that we will probably put in front of you. Okay, so make sure you're still trying to do that without the numbers too. Okay, so all of that, we plug it right in. We have 98 over 297 equals 83 over T2. What did you guys get for T2, my people who already typed it in? 251.5 is correct. And that is in Kelvin. So real quick, what is that in Celsius? Yeah, so in Celsius, we would have subtracted now 273, and you would have seen negative 21.5 degrees Celsius. So this kind of, I think, really shows that whole idea of the fact why we use Kelvin. It's because that's an absolute scale, as in it goes from 0 up. It never goes negative. But as soon as we put it back into degrees Celsius, now we have something that kind of makes more sense to us. Like we're like, oh, that's cold, right? Or something like that. So, so yeah, interesting stuff. Okay. Oh, the next one, Avogadro's. That's what your paper says. All right, so